Our following speaker will be speaking about cultivation and applications of seaweeds for bioplastic. Please welcome Mr. Philippe Lavoisier, General Manager, Eranova.
Good afternoon, everybody. Thank you for invitation. I will mention that United Nations this week we are speaking about the plastics and the plastic pollution. So this will be one focus to give you an idea of what can be done. What is today the citizen expectation? The government expectation and also the industry expectation. And this is related to the plastic. Plastic is 450 million tons per year. And out of that, I would say 36% is going on the packaging. And unfortunately, a lot of it is going in the ocean. So what are the concerns today with the climatic change? Many of them are the following. First, the plastic pollution, 8 million tons, ends up in the ocean, which is dramatic. Second, due to the climate change, there is also pollution from some algae. The Ulva lactuca, since we speak about it, is one of the polluting algae. In different places of the world, in China, in many places of the world. The other one that we mentioned, and you are concerned, is feeding 9 billion people in 2050. And the last issue is to feed those people, is to keep the land, not to use the land to make plastics. So that was the starting of our thinking. Of course, this is also relayed by the regulation. The regulation in the plastics is very hard. In Europe, every year you have new addition, and the tendency is to remove the single-use plastic, but not only. So we address two global issues. First is to try to solve the plastic pollution, and also, since we have to find a way, we say, why not using the algae as a solution? This helps us to fight against climate change. We use a sustainable material. We use less fossil plastics, but we also give some value to new chain of job. This is a new disruptive technology that we will bring to you. First, as it was mentioned to you, the algae has another big advantage, enormous advantage. It is the one that captures the CO2, 10 times than forest and 2 times than mangrove. So keep that in mind because now it's another issue, the CO2 capture. The algae say, okay, we can capture more than 50 tons of CO2 per hectare and per year. We can, and we are sure that we can capture 80 tons per hectare and per year just by using Ulva, but in harvesting. So we come back to the bioplastic, and like it was explained to you before, so I say again, most of the bioplastic were using land-based corn, starch, wheat, and all the food material, which is not possible anymore. The second generation was using waste, which are non-food, but again using land. So what we are proposing to you is to use the third generation of biomass, not using land, and this is the algae. So what is the purpose? The purpose is to say we will totally integrate the production. And the production is starting from the biomass, which is one. Then it was explained yesterday, the good thing is to get totally integrated in order to get more added value, not stop one brick to the other brick. The second part is to make the extraction, that means the biorefinery of the biomass. So we'll explain what we do. And finally is to find the markets that are demanding. So as I say before, everybody is producing material, but everybody has to pack the material to save the product for long distance and long time. If you don't have packaging, you will become using day-to-day product, but you cannot import and you cannot make traveling the product. So we go up to the end, and up to the end mean that we are making the packaging. And the packaging is mainly for food application. So we are doing rigid packaging, flexible packaging, and those markets that we address are for the cosmetic, for the food, and for all the technology. So what is the techno? The techno today is that we are using on our pilot plant located in the south of France. The collectivity are bringing us the algae. Why? They pay 3 times for the algae, for the pollution of the algae. They pay 1 time to collect. They pay. They pay 2nd time for transportation. They pay again. And they pay a 3rd time to make the treatment of the algae. But treatment of the algae is quite impossible. You have salt, you cannot produce methane. You have sand, you cannot go onto the land. So what are they doing today? They are putting underground and they wait. So it's again a pollution. Second, with the algae we get, we can put them on a raceway, so we don't put raceway. So it is inland, not offshore. Inland, you say, okay, you are using land, so you are contradictory with what you say. No, we are using industrial land. The lands that are removed from the traditional industry, we can use it to place our raceway. And the algae is enriched. That means we change the algae structure, the metabolism. When you use your reserve, you reduce your protein, but you create sugar. So we can adapt the algae. This is one topic. Second, we make the treatment of the algae. Of course, when you want to use algae in packaging, it smells and it has green color. People like the color, but people don't like also the smell. So we make a special treatment, but the special treatment is not with any chemical. And finally, we make the granule. So you have the life story of the algae. On the left side, we have the algae coming out of shore, which is dark green. Then we change the metabolism. It's become light green. Then we bleach it, we granulate it, we extract. The point is that we use all the algae. A part of it is starch, and the part of it is the fibers. So we are using 100% of the algae, and finally we get the products that are on the side. So we have different products. We have 4 kinds of products, which are biodegradable, which are compostable, which are durable, and all the composites. So we are using all the plastics that is needed today in the packaging industry, but not only in the packaging industry. So we can use any converter in the world can use our material and making their own product. So for example, we are able to make bags, we are able to make bottles, we are able to make glass. We get the award, packaging award with algae-based film to pack chocolate and to pack biscuits, and also we can do for trays. But this is one part of the application. The other part of the application is for the industry, for the construction. So for example, for tunnel, we can make the big pieces, and also for the harbor, we can do the deck. So the sea, come back to the sea. You are using a material made near the sea and for the sea. Okay, this is nice, but what will be the climate change impact? If you look on this screen, we make a life cycle analysis of the complete life of the product from the algae to the end of life of the product. And on the 9 points out of 13 points, we were positive. We have an LCA, if we compare with fossil plastics, that is 10 times reduced. And even with PLA, which is another bioplastics made from cornstarch, we reduce at least by 2. We go deeper because we compare with recycled plastics. And again, we earn some value. So let's think about what is carbon impact. Today, everybody say, oh, carbon impact, we have to finance innovation, we have to finance circular economy, we have to finance the green tech. All the economists say, okay, if we have to do that, we will have to impose a tax. If there is a carbon tax coming on stream, most of people agree that it will be 100 euro per ton per year. That means if you have 100 hectare land, I don't speak about earning money just by making bioplastics. I mean getting some additional value by the CO2. So this makes a lot of money in 10 years. And also you have the other advantage. You capture nitrates and you capture phosphates. What is the Eranova target? So today we completed the pilot plant. The pilot plant is 1.3 hectares in the south of France, fully operating. We produce 300 tons per year of bioplastics for different applications, different customers. For example, I can show you one product that maybe your wife will buy soon, which will be for L'Oreal and for the cosmetic. So it's coming soon on the market. And now we are on the range to set up a plant of 100 hectares that will be financed by European Bank of Investment and also by the French government. That means we will produce 27,000 tons of bioplastics. What is our program? Is a program to make it worldwide because you know that plastics is a mass production, is a mass market, and if you have customers like Coca-Cola or other customers worldwide, they will ask you, they will need from you that you produce everywhere, not only in Europe. So basically, we already sold a license in Indonesia. You say Indonesia is the second producer of algae, so we sell a license and they will do it locally in Indonesia. The second plant, which will be a Eranova plant, will be also in Morocco, where we find some land. And we have some other projects, and why not in Saudi Arabia, because you are a big country, you have all the climate opportunity, you have good expertise, you have a need for independence, not only to make bioplastic, but to make food, feed, to remove and to clean the water. So I believe Saudi Arabia would be a good place to be. And this is estimation, just taking into account the CO2 capture impact. So you will see with CO2 capture impact, you can finance all your plants in 10 years. This is nothing to do with the profits you will make with producing fully integrated production of bioplastic and selling the material. This is just the CO2 impact. So I hope I was clear. I will show you the samples if you wish to see for all the application I have with me. Right. And I would like to thank you again for your attendance.
All right.
Thank you.
Yes, that's okay.